Section 2.1, using inductive reasoning to make conjectures. Inductive reasoning, right here, that may be kind of a new term to you, but it's something that humans have been doing for centuries, millennia. Inductive reasoning is the ability to recognize patterns. All right? So how you learn as you grow up is you observe patterns. You observe enough things happening a certain way that you start to say, okay, I think I know how this rule is supposed to work. For example, I believe that any teenager who goes to driver's training already knows that a red light means stop and a green light means go. For example, my 3-year-old son, out of the blue in the car one day, we're coming up to a red light and he says, red light means we stop. And I've never told him this in my life. I think it's kind of an example of him observing enough times in his forward-facing car seat, when there's a red light, Dad slows the car down and stops. When there's a green light, we go. So it's this idea of making patterns. It's how our brain is wired to work. So when we look here at these patterns, it just says find the next item. It doesn't say what is the next item or prove that this is the next item. Just find the next item. Make a prediction. So we have January, March, April. Nope. January, March, May. So you look at this, you go, looks like they forgot about February. Looks like they forgot about April. So it might be July. Okay? Now, do we know that it's July? No, we don't. Because they're not telling us what the rule is. We have an idea or a prediction that we're skipping every month. So we'll make that prediction. 7, 14, 21, 28. It looks like we're counting up by 7s. Now we don't know that to be true, but that's the prediction we can make. An isosceles triangle facing up, facing left, facing down. So a guess is that the next time it's going to face to the right. So inductive reasoning, which our brains are kind of hardwired to do, to observe the environment and notice patterns. It's the process of reasoning that a rule or statement is true because specific cases are true. We've seen it happen so many times that we eventually make the connection, you know what, this is probably the rule. Okay? So it's on a discrete number of observations. A statement you believe to be true based on inductive reasoning is a conjecture. Conjecture is a really fancy word for prediction. You're making a prediction. So in example 2, complete the following conjectures. I got 3 of them here. All right, so pause the video for a moment, take a look at those, see if you can get some predictions, and then check my completed notes online to see if you match up with what I have. So when using inductive reasoning, conjectures, in order to show that they're true, you have to prove it. All right? Proving is pretty tough because you have to prove that it's true every single time. So unless you have an infinite amount of time on hand, proving something true through inductive reasoning is very difficult. All right? It's a whole lot easier to show something is false. You only need one example in which the conjecture is not true to show that it's false. And that case is called a counterexample. A counterexample can be a drawing, a statement, a number, some way of showing that the conjecture does not work every single time. So for every integer n to the third is positive. Now you have to play by their rules. It has to be an integer. So it has to be a positive number, 0, or a negative number. They have to be whole values, whole positives, 0, whole negatives. So can you think of an integer where n cubed is not positive? if n is less than 0, let's say -2 cubed, you end up with -8. So it is an integer. We're playing by their rules. It is an integer, but when you cube it, it is not positive. That would be a counterexample. So take a look at B, C, and D, and then check my completed notes online to see what you got.